Good afternoon. So today we will learn about what happens when light passes through different mediums. Just to note that this is page 7 of your notes on ClassKick. So please access ClassKick now and we will go through the questions on refraction. So recall that light travels in straight lines. So as I go through the lesson, please fill in the blanks in your notes. If that's the case, how can we explain this? We see that the body of this uncle is on one side, but his head is on very far away. So how is this possible? Is it like the work of spirits? No, as he said, physics is fun, so this is a result of physics. Refraction is the bending of light at the boundary between two different transparent medium, or what we call optical mediums. Optical because light can pass through them. This is caused by a change in the speed of light as it passes from one material into the other. Different optical mediums have different optical density. The more optically dense a medium is, the slower the speed of light. Okay, so imagine this, you are a light ray traveling through air. Now, if it's traveling through a medium that has the same optical density, it will be traveling at the same speed. Hence, it travels in a straight line. At the boundary where it meets water, it is traveling from an optically less dense to an optically more dense medium. So, going to a denser medium, it will slow down. And when it slows down, it bends towards the normal. Okay, so let's explore this using the simulation. Try working out on the simulation what happens when light travels from optically less dense to optically denser, so air to water, for instance. And the other example, what happens when you go from denser to less dense, say water to air? Does it bend towards or away from the normal? And what happens when I change it to glass? Okay, so try this for yourself and circle the answers here. Let us go through the simulation together. Okay, so let's look at this intro. Click here. And we note that right now the medium on top is air. It has a refractive index or index of refraction of 1.00. The material that's at the bottom is water and it has a refractive index or index of refraction of 1.33. So what this means is that water is more optically dense or optically denser as compared to air. It has a larger number. So note that this dotted line is the normal, and we use a dotted line again to represent something that doesn't actually exist. This is a mental construct that we are making so that we better understand where is the angle of incidence and where is the angle of refraction. So can you see that at the boundary where the light ray hits water, there is a bending of light. And we can see that it actually bends towards the normal. So say my angle of incidence is 30. If it's traveling at a straight line out, then my angle of refraction should be 30 as well. But we can see that it's less than 30. So we can say that it has bent towards normal. Now let's change this up to water to air. What happens? We note that when it's traveling from water to air, from something that's optically denser to optically less dense, the angle of incidence was 30, but as it exits the water towards air, we see that it's greater than 30 degrees. So this means that it has bent away from the normal. Okay, let's just try a few more examples since we have a simulation, right? Say instead of water to air, we go from water to glass. Okay, water to water. If it's the same refractive index, you can say that it doesn't deviate, okay? It will travel in a straight line. That's because the speed of light is the same. If I were to change from water to glass, what do you think will happen? Okay, so as it travels from less dense to denser medium, it will slow down. The speed of light will slow down and it will bend towards the normal. Hence, the angle of refraction will be less than the angle of incidence. You should have gotten the answer that when light travels from less dense to denser, it bends towards the normal. This is because speed of light decreases. Okay, or you can say it slows down. When traveling from denser to less dense, it will bend away from the normal. That's because the speed of light increases. So based on what we saw in the simulation just now, let's try answering the questions here. Over here, we have something that's going from air to water, something from less dense to denser. So less dense to denser, speed of light decreases and will bend towards the normal. So complete the light ray diagram by drawing a line that is bending towards the normal. So this is R. Okay, so with this example, can you try doing the other examples now? Complete up to example 4 and raise hand when you are done. Next, we want to look at what we call real depth versus a perceived depth or apparent depth. This is something that we did in the lab. So look at the image of these soldiers in the swimming pool. How tall do they look like to you? Do you think their actual height is shorter, the same, or as tall as how it looks like? Which means, do you think this man is this tall? Okay, does this happen to you at the swimming pool? So we are over at page 9 now. Try out this simulation yourself. Move the fish around and observe if the light ray refracts towards or away from the normal as it moves from the fish to your eyes. And hence, why is the image above the actual fish? So you can see that no matter how I move the fish, I would perceive the fish to be higher. The image of the fish is always higher than the actual fish. So why is that the case? Here, let me draw the normal. It's not very good. Yeah. Okay, let me just erase this so you can see the dotted line. Okay, so over here, we see that this was my light ray. Now, what direction is my light ray traveling from? It's traveling from the fish towards the eye. Okay, it's traveling from the fish towards the eye. So, this angle as compared to this angle, we can say that the angle of refraction is greater than angle of incidence, and hence this means that it has bent away from normal. Let's look at the other side, right? Okay, again, it's going from the fish up into your eyes. So this is my angle of incidence, and this is my angle of okay, my normal is not so good here. Let me. Okay, so anyway, what it should show is that the angle of incidence is also less than that than the angle of refraction. Okay, it's not so obvious here. Maybe I draw the middle one. Okay, much better. So, this light ray is going towards the eye. This is my angle of incidence, and this is my angle of refraction. So can you see that I is less than R, or R is greater than I, and hence is bending away from the normal. The light ray actually is refracting away from the normal as it's traveling from water to air. Okay, away because it is water to air, and this is denser to less dense. That's the reason why the image appears above the actual fish. So that's how we explain our answers in exam. When they ask you the question, first you state that refraction is occurring. The light ray refracts towards or away from the normal because it's traveling from, is it optically denser or less dense? Then does it bend towards or away from the normal? Hence the observation. I know that the object must be higher than that of the I know that the image must appear higher than that of the object. So draw the image in dotted line because it's not real. Then we pick a point from the image and draw a light ray to that point, from that point to the top of the eye. Okay, so say I pick this point to the top of the eye. Ray in water is in dotted line because this is a imaginary line. Oops. Okay, then we have the same point pointing towards the other corner of your eye. And I'll do the same. The ray in the water is dotted line. So what's the actual path of the ray of light is coming from this point of the object. Okay, so find the point of incidence and join them to the actual start point. So note that I use this point of the object. I use that point of the image. I must use back the same point on the object. Okay, so this is how you draw the ray diagram explaining real depth and apparent depth. Okay, if the eye is directly above the object, we see that the image is directly above the object. Okay, so draw again dotted line image. Point towards the eye. And then find the point of incidence and point it towards. Like so. Okay, so this is how you draw the light ray diagram for real depth and apparent depth.